just kind of hang out for a little bit and build a bit of trust.
Yeah, trust is critical.
Hello everyone. Yep, this is the Ethereum Engineering Group meetup. We're going to start in about 10 minutes. So, Brett, do you want to introduce yourself quickly whilst we're on widescreen?
Oh, while we're on widescreen. Hi, I'm Brett. I work in Pegasus, which is one of the spokes within Consensus, and we are responsible currently for building a new Ethereum client. So the conversation today is going to be about Ethereum 2 as it's seen at this moment. Big caveat.
All right, sounds good. All right, so we'll see you all in about 10 minutes.
I will probably repeat that a little bit in some ways. When do you choose to record those?
We are recording now.
Oh, okay.
Because what happens is that if you start recording now, then you're able to get the live stream happening.
Yes.
And then, so no one's on the live stream, but it's so that if people do just turn up to the channel, then they can see it's streaming now, and they can just click and join the live stream. And I don't call it editing. That's why I do the hi, please fast forward 10 minutes.
Yep.
Yeah.
Cool.
It seems to work pretty well. So at the end of it, I just go in, and then boom, it's uploaded, and then I just go in sometime this afternoon, and it'll just have live stream and blah blah blah, and then I just rename it, put in the link to the slides, and we're there.
Yep. So I've got sent the PDF. You probably want to grab the latest. I think there was only one change last night. Sometime around the time that I talked to you, I think I talked to Ben about 7 o'clock last night.
Yeah. Okay.
But it'll be minor. In fact, I'll even be pointing it out in some ways, purely because there was it's part of the things are changing so much.
Yeah. Okay. Well, look, I think everyone will be okay.
I'll also move this deck over into our repository as well, because it's still in my local point. I have to drag it across, unless you did it.
I did it, but it's probably now slightly out of date. So
okay, I'll do that. I'll move it over there at some point.
Okay.
Cool. I just don't want this to go to sleep, because otherwise it could all go horribly wrong. So I'm going to hope that it doesn't go to sleep.
Just touch it.
Yeah, just wake it up yourself. This is really good talk.
I was expecting this to be a bigger one. It seems more genuine controls.
Yeah, this is you're imagining you're in the Ethereum space. You say, I'm going to tell everyone I'm going to take 2 hours or whatever, and I think it's the city or wherever you're going to come from. We do tend to have about half a dozen people on the live stream, and depending on who they talk, sometimes we have sometimes we might have quite a few but yeah, the one that we did last week, I think we had not that famous. And we're up to 123 people who are subscribers to the channel. And it seems to increase by 10 or 20 each week. So, we're still a long way off 15,000, which is how many people are on the Ethereum Foundation. But, it's too bad.
Yeah, it's interesting stuff. I like this one as well because based on theory, it's really interesting what can we expect or what we know about that we should know for someone.
Well, I mean, this is where it's all headed. See, I would have thought that anyone and everyone who's involved in the Ethereum space is Brisbane and should be here. Maybe they can see that they sort of know what's going on.
Yeah.
But given how often it's been changing,
we'll see what happens. I've got a great crowd behind me.
You're going to phone it.
Yeah.
If there are any tricky questions, you just phone a friend.
I will. Well,
I'm just looking for questions on the internet.
Thank you for that. I do have this policy that all hecklers have to come up the front, introduce themselves, and then sit in the front row. By the end of
Debated front row about
I was going to say, no, it's going to be the front row. My perception is that by the end of the talk, all of you will be sitting in the front row.
Yeah, no, it's going well. A few growing pains, but yeah. Just the level of deals that we're getting with people that are talking to us.
Yes.
It's out of this world.
Oh, that's great.
Yeah, it's a good problem to have.
Mm.
Yeah.
Yeah. No, that's good. Yeah. No, so that's really good. I think they're trying to, having a lot of customers. Or even if there are a lot of, I mean, I know, I know at that point, a lot of people coming to you to try and find things. But it's a matter of trying to convert interest into
I think we're lucky we've just taken on a new COO, David
Up until tomorrow.
one of their top guys. Still in my car.
Yes.
Which is a big role, I think. $3 million, $7 million a year. So he's the money guy. He's showing me the money, he's the guy who work us through that.
Yeah.
So it's really interesting set of skills and that he has that we don't have. So
Okay. Yeah, that's really good. Yeah. Well, we're really expanding.
Yeah.
I think we've broken 40 people. Just so they're not just I think some things are right for up to 1,100 and stuff like that.
Yeah. Are you still grabbing?
You still at Bradley, they've become really good. I think that we're at new locations. So Bradley is opening up a new just down to one of those.
Okay. So we just got the opposite. Up at 320 that's not too bad. Good option for us. We've got a little office under us. Maybe wide as this table and as deep as the room.
Okay. How much is that costing you?
The final price will be monthly like $4,000. They'll have there's meetings there, credit system, pay rooms. Right now your first 3 months are half price. So we just kind of try and $2 or $3 grand for a month. It's pretty cheap for us. So just having the focus space where we don't have to share and compete for meeting rooms or anything like that. That's worth it.
Yeah. That could be good too. Yeah, but I think we were trying to discount.
A lot of chairs, not a lot of people.
We'll see how we go.
I think there's more around.
It is a lunch.
It's hard to know where to look, but there's cities full of corporate spaces.
At the start of the year,
That's full of crowds. But after
but I mean, this will be the fourth opportunity.
Yeah. 40 people.
Well, that's across the board.
Okay.
In Brisbane, I think so there's other people who aren't and then we have the people who are speaking for some company. They it's all been happening. He sent me a photo and he said, the work and he has this piece of metal, piece of steel that's work cut, jet, so you can put a jet, and and then guess it starts.
You do a 10 centimetre sheet of metal, it's a whole other thing. The water jet, it uses its garnet laden
Normally,
and basically,
Yeah, that's
can't
right.
leave it
That's a
anyone's
concern.
the hovering on the wood. Yeah, right. Well, no, I'm pretty sure there's some limitations on
Because you know it's going to do it, right?
How are we going?
Yeah, a minute or so?
Okay.
I've got a whole minute depending on your time.
Well, and sometimes we'll have about half a dozen people pour in 1 minute late.
Oh yeah, I expect to turn up just about halfway through the last part. That's the first part, which is going to make life interesting. Baseline understanding
Oh,
of
that's
stuff.
okay. They'll be on the video live stream up in there.
Yeah, no, because it's like most of this, the promise of the digital network community that goes through buildings really includes Hi! Should we kick it off?
Ah,
Hello.
hello.
There's more people. Awesome. Weird faces.
All right.
Shall I stand up here and floor or something?
Yeah. Well, then, so we're
Insert silliness?
yeah, we're just in this little frame here. So, hello everyone. So, Brett, you should introduce yourself again for those people who've just magically skipped forward 10 minutes.
And for the room that they can't see.
And for the room, yeah. So, hello and welcome everyone to the Ethereum Engineering Group meetup for today. Brett is going to tell us all about the future. Over to you.
Awesome, definitely the future. So welcome, my name's Brett. I work in Pegasus, which is one of the spokes in Consensus. We're primarily working on building an Ethereum client. So while I'm part of the development team associated with that, we also have a fairly large research team, which is great because I've been able to leverage them for a lot of this, because most of what you're going to see here is still very much up in the air. And in fact, I'm going to try and give you a bit of a feel for that as we go through it. So today, to do this, take you on this bit of a journey, I want to kind of talk a little bit of brief history, both of Ethereum 1 and Ethereum 2 to today, to kind of set some context. We want to talk through what is the current view of Ethereum 2. You'll hear me talk about current quite a lot. And then a closer look into the various pieces that make that up. I originally wanted to do a deep dive, and then I started to get deeper into it myself and went, yeah, most of these things are an entire talk in their own, and maybe more than one. And then finally, want to wrap up with a little bit of what's next, so some of the challenges, but also I've got a couple of slides that I'll just quickly flick through at the end, which gives you some of the links to the various things that I read and used to get to this stage. I also want to acknowledge a couple of people who've helped out. So Ben, who also works in Pegasus, is in our R&D team. He's heavily involved in Sharding, has been involved in a lot of the community regularly, has helped out with some of the reviewing and clarification and additions of last-minute changes as part of the spec. And Xiao Wei, who's also part of the Ethereum research team outside of obviously Consensus and Pegasus, and I used a couple of her slides with authorization for this. So let's kick off. Brief history. Ethereum 1, it kind of helps to understand that Ethereum 1 started back in 2015, but a little bit before, but the first release, obviously mainnet, was never the original and only release that was planned. There were additional releases planned, right? Homestead was going to be the next one. We also had Metropolis, and the last one was Serenity. Now with Homestead, launched in 2016, we basically did a number of big changes in there in terms of transaction processing, gas pricing, and improvement in security. And then we've got a decent gap, as you can see, of over a year before the first half of Metropolis came out, Byzantium. The second one is Constantinople, to be decided. Serenity, not even being thought about in all honesty. And really Metropolis, the big story around that was, of course, it required a hard fork. And why did it require a hard fork? For two major reasons. We needed to introduce some new precompiled contracts to support ZK snarks, and we also need to throw the difficulty bomb out a little bit further. And for those who don't know what the difficulty bomb is, it's really the difficulty ramps up significantly in an attempt to basically be a forcing function for proof of stake. And we still haven't got the proof of stake, so hence we need to push that little thing out a little bit further in terms of block number. Okay. Over this time, this is a relatively recent Ethereum block utilization since the early stage in 2015 through to reasonably recently. And what we want to capture here is just that if you ignore the few spikes at the very around the 2016 mark, which are the DAO and the some hacking that occurred at that point, or some spamming, really middle of last year we started to take off. And what we're finding now is utilization is averaging around 80% of the entire network. It spikes with things like CryptoKitties as high as 95%. So you can imagine that this thing is growing, but it's got a bit of scalability problem there, right? So unsurprisingly, Ethereum 2 is going to be a lot about that. So what are the goals? The goals at a high level for Ethereum 2 as it is today are around these three topics. We've got scalability, proof of stake, and enhanced decentralization. Okay, scalability. So the mainnet currently processes, I believe, about one block every 15 seconds, which roughly translates at its peak at around 15 transactions a second. We need to be looking at thousands. To put that into perspective, 15 per second. The data I was able to pull briefly, PayPal is 193 transactions a second. Visa is 24,000 transactions a second. And if you just stop thinking about just pure financial monetary transactions, if you start talking about financial exchanges, we're talking 100,000 plus price transactions and updates a second. This is nowhere near what we need to be if we want to move people ultimately to the Ethereum network. Proof of stake, we all know it's currently proof of work. There are problems, we'll talk about that in a future slide. What we want to do, why do we want proof of stake? Well, it brings finality. It also helps with security, and again, I'll talk a little bit more about that as we go through this. Enhanced decentralization. Not necessarily as obvious when we first talk about it, but with proof of work, as we all know, you've got mining rigs, you've got specialist hardware, and there is a centralization that occurs when you have that around consortiums coming together. So the two elements you've got there is not only you have a small number of people who have a lot of money who can put it into mining rigs that end up having control, but from a centralization point, you now have a small number of targets if you wish to disrupt the system. I think it was earlier this year there was a mining rig in either Finland or Greenland or somewhere like that was utilising the cold temperatures to reduce their power utilisation, and then one day they came in and most of their hardware was gone. So you've got that element, right? The ultimate goal is this last one. So one of the reasons proof of stake is on the table is we want to bring it down so that commodity hardware, this laptop, can participate actively in the consensus of an Ethereum network. Okay. Let's bring this forward a little bit timeline-wise. And there's an element to this whole story and journey we're going to go on that'll give you an understanding of why this is all potentially different in a week's time. So in 2014, Ethereum 2, Vitalik made a post that basically said in 2016 Ethereum 2 will be out. Or a little bit behind that. The second half of last year, the two main parts that are associated with it, which is Sharding for your scalability and Casper for your proof of stake, were pretty stable. The specs were solid, people had known about them. And then in March 2018, a completely new spec came out proposing improvements that were actually really quite good for Sharding about a week or so before a major conference in Taipei where most of the people in the community working on this were coming together. So that whole conference changed, which was good. They got to talk about, debate and do that sort of stuff. And then in April, EAP 1011, I think it was, came out, which introduced and started talking more about Casper FFG on mainnet and how we might be able to do that. And then in about June, everyone went, well, you know what? There's a lot of commonality happening here with these two. Maybe we should just merge them together, right? And a really annoying name turned up, and we all know it's going to stick. And it's basically Casper FFG and Sharding, and so someone's coined the term Shasper. But if we look at this, the commonalities here are the key, right? Why people are thinking about pulling these two together. Both of them require randomness, right? So we've got that challenge, but we need it for Casper for block proposers, for Sharding for both the validators and the shard proposers or the block proposers. Staking, the big thing here is that by unifying all of this, we can reduce the cost associated with the staking. And for those who don't know what staking is, we'll talk about that when we get to Casper in a minute. Shards run on proof of stake, so we need staking, right? Slashing is a whole new element, which is how we kind of deal with the potential for bad actors in the system. Okay? And finally, to increase all of this and the number of validators, you start talking about things like aggregate signatures. So there's quite a bit on the board here that is common between the two, so it makes sense. Let's bring them together, let's unify this whole process and see what we can come up with. And a little bit further into the process, you'll see me talk about a thing called beacon chain, and that's pretty much where this all came to a head. So, let's talk a little bit more now in detail around what is the current Ethereum 2.0. And as you can see by the timeline, the reason why I wanted to give you that background is because ultimately all of this is changing, and it's changed really quickly just relatively recently. And so you've got more people interested, more people working on it, so you can imagine this could all change again in a couple of weeks. So what's proposed? The elements we want to talk about are really in these main areas. We want to improve concurrency or speed, right? Consensus, proof of stake, pretty obvious. State transition, how do we deal with our transactions? Some of the underlying pieces associated with peer-to-peer networks, so what's going to be, what changes may be required for that, and then what crypto improvements are being proposed. So if we start with the obvious one first, Sharding is going to be the one we're looking at then, and the second most obvious one is Casper. Okay, particularly Casper FFG to start with. State transition, EWASM, is making a head in that, and people are looking at that as being a way, initially to be improving speed, but it's also an opportunity to introduce that. With peer-to-peer, we're currently on dev P2P, lib P2P is being looked at for various reasons we'll cover a little bit later on. And then with the crypto, there's a number of things. We've already talked about slashing aggregate signatures, but there's also randomness, kind of a key driver for all of this area. Okay. This, thanking Xiao Wei for her original diagram, is a high-level architecture that's currently being considered. So if we look at this, we've got our main chain or main net at the top, and it's really for staking, right? It's where, for those who are concerned, and in fact, when a lot of this was first presented to Joe, the very first question Joe Lubin, as in consensus, raised was, what happens to my ether? Nothing. We need it. Okay? It's still part of the whole process. Beacon chain, you've heard me mention, and beacon chain is really all about that coordination. Right? how do we coordinate the shards? How do we coordinate with respect to proof of stake? How does all that element? This thing here is really busy, right? Randomness, proof of stake, shard finality, finality, shards, and how they maybe communicate between each other. And speaking of shards, obviously we have the shards down the bottom there, which are effectively entire blockchains fully self-contained in their own way, right? When I first put this slide deck together, that was 1 to 100. So about a month or so ago, it was they were suggesting there could be 100 shards. I believe the number now is in excess of 4,000 shards is being proposed. There could even be as high as 10,000 shards. What the big question there is, we don't know what the number of shards are likely to be, because they're going to have to essentially play with it, benchmark it, see what makes sense and what's the optimum that they be using. And the final layer is the VM layer, which is your transaction processing. I'm not going to talk about this today, but one of the elements that has been discussed here is delayed transaction processing. In other words, instead of currently your nodes are processing the transactions, all transactions on the fly, the idea that's being proposed for this bottom layer here is about maybe when you inquire about the state of your account, then the transactions are processed at that moment to give you your current balance, as opposed to all of them having to be run every time. A lot of controversy around some of this stuff. Okay, but another way to think about this architecture is we've got our anchor layer. It's still there, it's our anchoring point for all of this. Coordination layer I've already mentioned. We can think of this as our data. The shards are really the data and ultimately the execution layer. Okay, so keep that kind of in mind as we go through this. What I want to do now is talk a little bit more about the elements that make this up. Okay? I will pause. Any quick questions around this, or we're happy to keep going and hold questions to the end? No? Excellent. Let's move on to a closer look at some of this stuff. And as I said, it's not a deep dive, but we're going to start with sharding. So, today, as you I'm sure all know, every node holds the entire state, processes every transaction, which means we've got a single pipe of transactions, which means that our world computer is single-threaded. Obviously, one of the many reasons we want to improve the speed of the system, right? What does that look like? Well, if we take a typical node on a block, on the blockchain being able to process C transactions, the mainnet can do an order of C. And that's where we're at this moment. So keep that in mind as we look at what we're talking about with shards. So one of the challenges with what we're trying to do with blockchain is the various properties. Scalability, obviously we want to process more transactions, we want to be able to have more people involved, we want to have more things happening on it. Decentralization, right, enabling censorship resistance, being able to have that open to everything and limiting problems. And then finally, security, the immutability of ledger. We need, obviously for this to work, we need to be secure. And so there has been what's coined the performance trilemma, who I believe Vlad first proposed. I have heard Vitalik refer to it also as the scalability trilemma. And the reason, of course, that he's talking about that is that the current release, what blockchains have been focusing on, are on those two elements. We needed to get decentralization, we needed to get security, but what about scalability? And there's essentially a belief that you can only have two of these. You can't have all three. And so what sharding is here to try and do is to try and give us all three. Okay? So what is sharding? You'll hear the term galaxies, but basically they are fully self-contained blockchains running. Okay? Multiples of them, all running off the same proof of stake consensus mechanism, right? Which is the same as what's on the beacon chain. So effectively taking what we've got today, but using true proof of stake, running across that, and then having multiples of them. To give you a feel for everything changing, the second one of these, as of last night, I had was called validators, and I was informed that it's now called attesters. So a lot of this is changing. But if we look at this, this is an element associated with sharding, right? So we have our proposer node. It's most likely or probable at this moment that there'll be one per shard proposing the blocks, right, to put out there. You'll then have your attester or validator nodes, and their job is to validate and confirm and to sign an agreement that that is the next block on the chain. Okay? The executor nodes falls back to that previous comment earlier, and so with that potential that the execution of the transactions may be delayed, you end up with executor nodes. It's expected, at least initially, that both the attester and the executor node will be combined into a single point. Okay, so you won't have separation at that point. Okay. Sorry, it's correcting me. So the other, I guess, element to think about when we're talking about this is that we talk about the beacon chain being the coordinator. One of the keys here is that we need to ensure that validators or attesters don't get to live for a long period of time on a single shard. You can imagine that if, you know, a group of us all happen to live on the single shard, then we get to control it. We get to say what is and not a valid block. So part of that randomness, part of the beacon chain coordination is being able to move which shard you're responsible for at any given time for validation. Okay. And when I talk about beacon chain a bit more, I'll kind of give you a view into how it's perceived that may work. So what does all this mean if we've got all these wonderful shards? Well, we talked about main chain being able to, in this case, watch C shards. And what that potentially means is that we have a quadratic increase. Because, of course, each of our shards down the bottom can process C transactions, even if we stick to what we can currently do. So this is envisaged with, people have talked about, and when I get to it, EVM being one of the potential ways to increase transaction throughput. But in comparison to sharding, this is the one that everyone believes is going to be the bigger, most performant upgrade we can do. Okay. Okay, moving on. Casper. Today we have proof of work, which I'm sure we all know pretty much what the basics for that are. We've got a cryptographic problem, takes a fair amount of energy and processing power to be able to solve, hence the mining rigs. The verification, however, is relatively simple, and the miners are rewarded through transaction fees. Basically, at its simplest, you solve the puzzle as hard, verify, easy. What's the problems with that? Well, start with the obvious one at the top. It takes a lot of power. It's been estimated by a company called Finality that since the beginning of Ethereum, at least, if not both Bitcoin and Ethereum, that we've generated probably about 261 million tons of CO2 just on mining rigs alone. So if we're trying to change the world, we are, but not the way most of us would like it to. Okay. The other element, of course, is proof of work requires fairly serious hardware and specialist hardware, so it's vulnerable to ASICs. We've got a group that, you know, I can't necessarily do successful mining on this machine. And we've seen some of the impact of that. If you're a gamer and you want to buy a graphics card, the prices all skyrocketed a few years ago, as we know, as people started buying up graphics cards, because GPUs are really good at this. Okay? There's no finality, so we get, what's it called, sorry, block reorg happens and can happen. So bringing finality to this is the final block is an element that doesn't exist in proof of work at this moment. And then finally, there's a randomness associated with block times. And what do I mean by that? Well, I've mentioned that it's an average of 15 seconds for a transaction to be processed, but it's an average. 1 second after the last transaction was processed, the next transaction could be processed, or it could be 1 or 2 minutes. And so there's no consistency there. When you put a transaction on the network, you don't really know how long before it's going to be processed. Okay? Welcome proof of stake. So the big change, obviously, is we get rid of miners and we introduce validators. Validators, as its name says, stake coin. They stake a certain amount of their interest in the blockchain to be a validator. Okay? Validation is done by betting or voting on the blocks, and based on stake, the reward is proportional. So what we now have is, because the processing is so much less, potential for machines, phones, other things, maybe to be miners, and start to increase. It's going to depend again on stake, how much you want to put into it. But it's not without its problems. There's a term called the nothing at stake problem, which I'm going to try and hopefully make clear. If your cost associated with validating something is essentially zero, then there's no incentive not to validate any forks, both forks at the same time. So the nothing at stake problem shows this. We have a fork has occurred, okay? And I'm going to be the bad actor in this story. I've got a 1% stake, and I hold off on that. And what I do in, say, block 12 of both is on the yellow chain, I send some ether off, converting it into fiat. On the other chain, the red one, I send that same amount to another account that I happen to also own. Double spend, right? What's the problem with this at the moment? Well, we've got both of them going along, so both of them are valid transactions. Except when we get to the next block, when I put my 1% validation stake against that block, and that now becomes the new correct branch or fork. So I've cashed in my money and I've kept it at the same time. Now there's some problems with this, right? Ultimately it requires all the other validators to be validating both at the same time. But it's still a potential, right? And ultimately what we want to do is we want to try and deal with this potential. So introduce the Ethereum Proof-of-Stake. There are actually two of them. There is CBC, which is a true, pure proof-of-stake, which is the one that Vlad has been working on. And Vitalik has proposed FFG, or the Friendly Finality Gadget. Hence the note up the top there about where Casper came from. Which is really a proof-of-work, proof-of-stake hybrid. It's proof-of-stake overlaid over proof-of-work. Right? And the way we deal with the nothing at stake is we punish bad actors by taking that stake that they put in and making it go away if they're playing unfriendly in the pool. So Casper FFG is the first effect of what we're looking to do is introduce it. So it is proof of stake, as I said, overlaying proof of work. It provides us a transition to ultimately a full proof of stake. So it gives us the ability to keep proof of work on mainnet. Proof of stake is happening on the beacon chain and ultimately on the shards. And what it also does is it provides finality, which is really the big part of what proof of stake is going to also give us. And it's currently, well, it was, I've been told now that as of 2 days ago, the particular document we've got which combines both Sharding and Casper FFG has now proposed that it's probably more likely every 64th block. Welcome to the world of Ethereum 2. Tomorrow it'll be different. I'll talk about some of the challenges associated with that a bit later. What is finality, or why is finality important? Well, effectively what we're talking about here is total economic finality, 2/3, maximum on bets, and where there's a de-incentivization to collude. What do I mean by that? So if Alice and Bob decide to collude on one fork, and Bob and Charlie collude on a second fork, at some point, Alice or Charlie are going to lose and lose big time. So why would you do it? Right? You're going to lose. The risks are high, and the risks are your stake. Right? As Vlad put it, I particularly like that comment. 51% TAC is the big known problem within proof of work. what Vlad basically said is proof of stake and slashing is the equivalent of every time you get caught out, you burn your ASIC down and start again. Not really fundamentally a good idea. Okay. The double finality is an interesting one. If you do have a fork and you have a hard fork, it is a hard fork that the user group essentially agrees which is the valid fork and moves forward with, and the other one's essentially shut down. Which means if you took all your bet and you put it on the wrong one, you're kind of in trouble. I'm going to preempt any questions. I have no idea how they're going to implement that. But that's kind of the thinking around what Vitalik's talking about with this total economic finality. Okay. Beacon chain. It is, as I said, the coordination layer. And so really it's got a lot to do. It's got to deal with randomness. We talked about both Sharding and Casper require randomness. So we've got to have some sort of control or some sort of random beacon that we can run through the whole system that you can leverage. It manages the pools, manages your slashing and your staking, your checkpoints for your shards. What it isn't is it's not programmable. It will not have a VM. You can't send arbitrary transactions to it. It is literally just a coordination layer. And if you remember back to the original diagram, it sits in parallel with mainnet. Okay. So, what's the big advantage in some ways of this? It's all about the pool of validators. Okay? But basically, pulling the management of the validator pool off mainnet, right? So in the early stages, the idea was that you would have two smart contracts running on mainnet. You'd stake for your shard validation and you'd stake for the proof-of-stake validation. So not only did you have to double stake, so that meant that you needed to have a lot more money if you wanted to be in both. It ultimately meant that you've got a lot of processing on, as we showed earlier, a fairly heavily utilised network already. So by taking all that processing off mainnet and putting it into here, basically you can build the beacon chain such that it's more performant around that, but not impact on mainnet doing that. And in doing so, you can crank up the number of validators. And that fits to the second section, which is our security level. More validators, increased pool of validators, means that you reduce the probability of having some bad actors. You haven't got rid of them, they're still there. It's just you've got a bigger pool. And if I remember correctly, and this is where it gets a bit fuzzy for me, effectively you want to reduce the risk to below the 50% that you're going to have a bad actor or a number of bad actors in your current validation pool that's being used on the current shard or proof of stake. Okay? So this is a diagram basically representing the concepts around the beacon chain. You've still got your main chain at the top. But as I said, the big key here is that the original stake was going to be around, I think, 1500 ETH. And it's been able to, because we've now been able to crank up a data I don't think I've got on this one, might be on one of the other slides, but I think we're now talking maybe 300,000 validators could be a possibility. As such, the stake has been able to be brought down, 32 ETH. More people are likely to be able to play. We talked about that earlier, decentralization, more people involved. The idea being that you would stake based on the smart contract, your 32 ETH, that would basically then move you into the pending validators pool. Based on the randomness, you get picked to be one of the current active validators, and then ultimately your validation voting associated with the block, as we talked about earlier. Okay. At a regular cadence, you also want that to be writing finality. Now, if you want a lot more technical detail about that, I started watching a very interesting video from Vitalik from, I think, July, where he started to do some real-time diagramming of how this all works and how it might be architected. Lost me about partway through. Okay. So we've got that, all the two big elephants in the room off the table, which is sharding and proof of stake. But as I mentioned earlier, there's other elements that are being proposed for Ethereum 2. And a lot of those are ones that have been around for a while. People have been putting their hand up saying we should do this for a while. And others are there for support requirements for some of this stuff to work. The big one everyone's heard of, I'm sure, is EVM. So currently we've got the EVM. And if you want some really interesting presentation on that, there was one of those a couple of weeks ago by Chris around how the whole stack processing, how it works. But basically the summaries level, it's a 256-bit architecture. It's currently primarily 2 languages that support it, as in Solidity and Viper, which again we did a talk on that just recently. But it also requires precompiled contracts, and I'll mention what that means in a second. So its big problem, in many ways, is the 256, right? It's not a great match to current hardware, which means all opcode, 256 opcodes need to be split out. So now we've got CPU utilization increasing. I can't remember the exact number of opcodes, but if you want to add 2 256-bit numbers together, it's I think 4 or so opcodes for a 64-bit, and it's something ridiculously higher that you end up having to break it down into to do the actual CPU. Part of the reason behind the precompileds is because the EVM is not that efficient. And so if you want to introduce your new favourite cryptographic curve, elliptic curve, to the process, you can't do it in a transaction. It's too costly. We talked about the hard fork that happened with Byzantium to introduce a lot of the stuff associated with ZK snarks. And that was because we needed to have precompiled contracts. Precompiled contracts, and the reason, again, hard fork, is that all the clients need to be updated to include them. So if you want to introduce new things, you need to go through quite a longer cycle. So that introduces the other risk associated with this, which is your cryptographic agility is as fast as you can get the change rolled out into all the EVM clients. Okay? We've also got, as we talked about, only 2 languages, so we've got a bit of limitation in that, and we've got a fairly small developer community, the current clients, that are doing improvements and working on this. So the one that everyone talks about is EWASM, or an Ethereum flavour of WASM, or WebAssembly. Why Ethereum flavoured? Well, for 2 things. We have a mostly Turing complete engine. Part of the reason we don't have it fully is the gas metering. We need to kind of limit. So there will be the need to still involve that in the EWASM. But also we need to have determinacy for consensus to work properly. So while there are elements of floating points, consistency across software, it's not always carried across through hardware, so it's just easier to get rid of floating points. Okay. Brief, what is WebAssembly? That's taken directly from webassembly.org. I'm not going to read it out to everyone, but effectively it's a virtual machine, high-level language support. You'll see the word client server, you'll also see the word browser in a lot of places. Okay. So moving on. What's good about WebAssembly? So it's an open standard to start with, and it's got quite a lot of support through the community. You've got people like Google and Apple and Microsoft who are out there. It's supported by a W3C community. It's got quite a large range of implementations out there in different languages, and it's got strong support. And by that I mean there's a lot of languages that you can compile down to WebAssembly. So really the big goals around EWASM. Fast and efficient, the same as WebAssembly. The idea is they want it to operate at near native speed. The big one for me, from my perspective, is the security. The lack of precompiled contracts makes that massive. If you want to have your favourite elliptic curve, you can write it now in a transaction as opposed to relying on a precompile. C, C++, Rust, I think JavaScript, though I don't know why anyone would necessarily want to write contracts in those, but it's possible. The last one's an interesting one, though again I don't know whether this is a reality or what it might do for us. But the potential for you to write once, run anywhere, and we all love that statement, but write an application that you could run on the blockchain, or you could run in the cloud, or you could run natively, would be kind of nice. Right? Okay. Peer-to-peer networking. None of this stuff works unless we can communicate. And the front runner here that's been talked about for quite a while is libp2p. So if we look at dev P2P, what is it? It's Ethereum specific peer-to-peer protocol. Interestingly enough, when I first started looking into this and some of the early papers, it actually classified libp2p and dev P2P in the same sentence. And then a few months or so later, they actually started to split them out and specify libp2p was different to dev P2P. It's got those main elements, your node discovery, your LPX, right, for peer, for transport, and then, interestingly enough, dev P2P as an application layer is its own name. So you've got those elements that make up the current network. What's the problem with that, though? Why can't we just keep using it? Well, the first one is there's not been a lot of actual work being done on that. I understand there's pretty much only about a handful of changes that have been done on the protocol since 2014 when it was first brought out. The second one, and probably the one that really impacts on Ethereum too, is it's not got any understanding of network segmentation. So how are we going to send messages to a particular shard across dev P2P at this moment? So the push has been for libp2p, and what is libp2p? Where does it come from? Well, if dev P2P is the peer-to-peer network for Ethereum, libp2p is the peer-to-peer network for IPFS, which, by the way, I had to look up because I had no idea what the hell that was. It's that networking layer pulled out of and separate, so it has its own repo and it is separate from IPFS. It's modularized, it's extendable, right? It's transport agnostic, fairly handy. From the actual site associated with that, their design goals, the implementation goals is this list here. I'll leave them up there for you guys to read for a minute. But really the biggies from my understanding is things like transport agnostic, NAC traversal, reuse, connection reuse, okay? Next slide. There's also elements about, you know, how do we locate peers more efficiently than we do today. Okay. So the current modules, and some of the current modules that libp2p has as part of its specification are these guys here. The one I was trying to remember earlier is, they call it content routing. Some people here might know it as distributed hash tables. So that ability to do lookups as opposed to seeding with a particular starting point of who are your peers to start with communication. So record stores, peer-to-peer discovery, crypto channels. So the goal, why is this valuable? So libp2p by itself is not going to necessarily solve our sharding communication issues. We're going to have a variation on it. And there's a stack of building blocks here that we can leverage to build that, I guess, sharding flavoured libp2p. Getting towards the end. Crypto improvements. There is a number of elements, some of which we've already talked about. And this is really more, this first one is more crypto economics than cryptographic. We've talked about slashing, and really it's fairly straightforward. Your staking reward is slashed for bad actors. The proposal that I've heard and read a bit about so far is fraud proofs or fault proofs. That is, we find you guys are there, a couple of you participate in that, you identify me as a bad actor, you show proof that I'm a bad actor, my stake is slashed, you get a reward for having found a bad actor on the network. Okay? Again, implementation, the devil's going to be in the details for sure. Next one is aggregate block signatures. This fits into that same conversation we talked about by having far more validators, or being able to have far more validators, improving our security. But if you've got a lot more validators, you need to be able to sign. The more people you've got signing a block as valid, the more work you have to do to verify that the signatures are right. Welcome aggregate signatures. Okay. The couple of big things here, we've already talked about that improved security being in that decentralization, bringing more people into the fold. The one that I believe is being considered at the moment is this elliptic curve, and if anyone has any questions about that, the man to ask is over there because I know nothing about it, and he may not either. But basically, it's not quantum safe though, and so Ethereum 2.x is talking about this lovely thing called a ZK Stark. It is not a ZK Stark; they're different. I have no idea what the hell the ZK Stark is. I only just vaguely understand ZK Snarks. So they're the next element that people like Vitalik and others are looking into of how do we do this. Okay. Randomness is key to a lot of the how do we ensure that our validator pools are random across the whole system. So both of them need this beacon, Casper and Sharding. Ideally, the other goal around the randomness is that it will be sufficient for use. So, there are, I can't remember the thing, it's one of the pokers, I can't remember what the name of it is, but basically you've got your blockchain pokers or other gambling or games of chance or other requirements where you need randomness. You would like to be able to leverage the same randomness capability. Okay. The one that is being considered, and I'm going to probably butcher its name, is Rendeo. Its big problem is it needs a VDF to avoid last actor. Okay. So again, still more research to work into how they might move forward with this. A couple of weeks ago, a couple of meetups ago, I think, Peter, you presented a proposal on this, or you did down at the Gold Coast. So Peter has recently put together a possible way for randomness on the blockchain.
I'm presenting in about 4 weeks' time.
There you go.
I'm going to scout on it, get a implementation open source.
There you go.
Work on mainnet. But I've got to build up to a few other things. Yeah.
Outstanding. So come along in a few weeks' time if you're interested in this. Peter's going to tell us a bit more about it, or at least about the potential way that this might also be solved and considered. Okay. The last one I want to talk about is account abstraction. One of the reasons I wanted to bring this one up here is because while it's not necessarily required for any of the stuff we've talked about in Ethereum 2, it's a really good example, a bit like EWASM, of what Ethereum 2 has also been used for. So account abstraction was originally proposed in April of 2016. So it's been around for a while. But we've talked a little bit about, the making changes like the hard fork required. Oh, sorry, like the introduction of ZK Snarks and stuff that requires hard fork. So making changes takes a bit of work and a lot of coordination. So what people are looking at saying, well, it's getting hard to put things onto mainnet. It would be really good if we had somewhere we could start again. And hey, we really like this and we'd like to come bring it onto the table. So this one's been around for a while. What does it really mean? So currently, transaction validation is hard set. Signature verification, nonce, and fee verification. So gas, right? Do you have enough gas to actually run this? With account abstraction, all your accounts are effectively contract accounts, and what it really means is the contract can specify its own validity. What does that mean in practice? So what that may mean in practice is today, if you have, it's an EC, what's the token? ERC20 token. If you have that, then if you want to do a transaction of those, you need both Ethereum or Ether and the tokens to be able to transact with the tokens, right? You still have to pay gas price in some way. This would allow contracts to just go, yeah, we're processing our fee is associated with the token, right? Or, because if we introduce stuff like EWASM, I can now have my own elliptic curve, I can choose to use a completely different signature verification process. Particularly like that one from the perspective of that crypto agility. We can bring that in at a later date. Transactions can then start to not rely entirely on the node doing it. Okay? So, that's where we get to. I think we're doing okay in time-wise. What's next? Well, I want to kind of cover a couple of things. I want to cover, first of all, some of the challenges, which you probably have guessed a few of them as we've gone along. The big one is really, since mainnet was released, there's been pretty much, other than Homestead, no major protocol improvements at all. So I've hinted at that earlier. There's basically that big inertia to get change on there. So moving all of this stuff onto mainnet, not really a possibility or going to take some work, so we want to limit the actual linking requirements, the updates required to mainnet for some of this to work. We've talked about shards. Well, that's great. They talk to each other, talk happily within the shard, but the big challenge is, how does a shard talk to another shard? How do I enact a transaction from my shard to your shard? Is it synchronous? Is it asynchronous? Lots of questions, no one knows the answer. Or at least no final answer. This one, though, is the one that I guess is the reason why a conversation today like this is going to potentially be obsolete in a couple of weeks or a month's time overall. This is genuine research. There's a lot of innovation. What traditionally happens is we as a group are working on the new protocol or the new system, and we happily beaver away in this room, we come up with something, we present it to the world, done. And then some discussions might happen about it, or it's presented finished. That's what it's going to be. The difference here is we're doing all of that, except it's out in the open. Everyone can see the mistakes, the hits, the misses, wow, this is going to work. As evidenced earlier, you know, sharding was fairly much a done deal until a couple of months ago, and then it got completely changed with some really, really good innovative improvements from what I understand. Okay? And the last one is, we haven't actually nailed down the spec yet. Until we do, how are we going to implement it? And then there's a lot of moving pieces we've just seen. There's a lot of stuff that's got to be built. So the other challenge is, what's it going to take to implement? What's a new client going to look like that can implement all of this, parts of it? Is there staged elements to it? A lot of questions we don't know. So to finish off, hopefully that's been at least a good intro to Ethereum 2 and some of the elements of Ethereum 2. I'd like to kind of, and the slide deck will be and is available, I believe, up on there, but if not, we can I can put the links directly later. This is some of the resources that I used along the way. I pulled out a few that I found fairly useful. I want to call out a couple specifically as I go along. The top one is a blog post written by Ben, who I mentioned at the very beginning, from the R&D team, talking about that journey in some ways and what's happening in the space. He was at Taipei. He actually read the change on the flight to Taipei and was involved in the discussions around that. He and some of the other members of the team there have also been involved in questioning or raising questions around some of the proofs that have been put together for some of this stuff. The second one is where I kind of started my journey. That's a really useful article written by a guy, I believe Rocket Pool is in Brisbane. And so Darren wrote that one. Again, it's a good starting point. Hey Darren, welcome. No questions from you. All future questions to him. Yeah, tempting. No, but I'm just going to redirect them to you if that's okay. And then the last one is a relatively new link that Xiaowei's put together, and it's trying to bring together this huge collection of different links of information. The Getter channel's there. There's also links to some of the stuff we've talked about, the specs and other stuff that is there. From what I saw yesterday, at least one of them's already got a cross through it. There's no longer being of use to people or something. So yeah, that's probably one of the places to go to try and start to pull up that information. Sharding, there is a PDF presentation by Vitalik. If you are maths orientated or understand some of that stuff, have fun. You'll enjoy it. I got lost fairly quickly. This one, however, is the one that is of value. That's the one that's changing regularly. I mentioned at the beginning, one of my points, the validators has now become a testers. That's the spec that's in flight right now. I think the update I saw the other day was like 3 or 4 days ago. Casper, that I found was quite a good introduction of crash course of the two types of Casper, both CBC and FFG. Gave a little bit of a good understanding of the history, but also what the two differences are. So that top one's on that one. Another one which is kind of going in, again, another blog article, Medium article I found very useful. And About 2 weeks ago, there was a tweet storm of something like 75 tweets by Vitalik, if you want to go and read those, on Casper FFG and kind of the history and where it came in. And I believe a lot of that has got a huge amount of links as well. So if you really want to get involved in proof of stake and understand it, I'd start with some of those. EWASM, I found that podcast. These guys have some really interesting podcasts. I know at least one person's already listened to a few of the others around the blockchain space. So they did talk to a couple of the people involved in the Ethereum Foundation around EWASM, and that's where the design repo is. So if you want to understand more about their design goals and what they're talking about. libp2p, there's not too much out there around it. It's been around for a little while. You can find some more stuff. Mostly it's going to be around the whole IPFS space, but that's where the repo is at the bottom there. The specification from the repo is there as well. It's a good place to start if you want to start down that journey of understanding that. And that's it.
Oh, well.
Thank you. All questions to that man just then.
That was fantastic, Brett.
Thank you.
I have a question to you.
Bugger. Okay, what do you got?
So, I've got like my 2 Ether on Ethereum mainnet. And magically 2.0 is whipped up. Do I have an account on a shard, or is it on mainnet, or can I transfer Ether to a shard? How does that work?
How does it work? Good question in the sense that no idea how it's going to work. Is it being considered? Yes. So one of the challenges is just that. At the moment with the current plan is that your Ether is going to live on mainnet. I mean, to Joe's question, no, you're not going to suddenly become poor. But there is that question of, can I transfer Ether of value from one shard to the other? Yeah. And so there is not just the transferring of Ether from mainnet to a shard, but can I then transfer from that shard to another shard? Mm-hmm. The answer of how it's going to be done, it's going to also have to do with how the shard-to-shard communication occur. Mm-hmm. Up in the air. I don't know the answer.
Do you think it'll have something to do with that communication layer, like randomness beacon?
The beacon chain? I'm fairly confident. So some of the things I saw around maybe how, and I think I even saw it in one of your diagrams, Darren, was that you may end up having some sort of, well, it can't be a smart contract on the beacon because it's got no VM, but some sort of element.
Monitoring that, Ether needs to be on the shard so it was quickly sent.
Yeah. The beacon chain's got a lot of work, and so you can imagine not only do we need to bed down what sharding, what Casper FFG is, how we want to do libp2p or EWASM and all that sort of stuff, we actually have to design what the beacon chain does. I mean, I listed, I think, 6 different things up there just for it, right? As soon as you start introducing it. So if you remember back to the original diagram, you had your anchor and then you had your coordination. And everyone and everything I've seen around beacon chain is, it's the coordination layer. It's going to be the one that helps do that. All the heavy lifting is done elsewhere. So you pull that out and use that parallel element to having different shards, maybe different VMs underneath that. But that's the one that's going to do that. So I suspect that's where it's going to go.
What it looks like will happen is that you'll deposit Ether into a smart contract on the mainnet, and it'll effectively be you'll actually deposit 32 Ether exactly, and you also define a withdrawal address on the shard, and that's kind of what looks like it's going to happen. And what actually happens is that it will burn your Ether on the mainnet and it will appear in the shard. That's for staking. How
actual
user would actually transfer numbers, but for staking, it's by that process of a smart contract. Because the beacon chain clients will be listening to mainnet as well, they'll pick up the fact that you deposited into that contract and then add you as a validator into the validator. That's one way of getting into the new system, but how normal
still doesn't affect the normal usability. It doesn't make it smooth, basically, for an end user to not have to think about all this.
Not at the moment. I mean, the big challenge again is how do you implement all of this, right? Do you create the beacon chain first and then give yourself an element of proof of stake, and some of that gets put into play, and so it's just an overlay. Then do we implement sharding second, and that then gives us our performance, and by that stage we've started to consider how shard-to-shard comms work, but we also have to then solve the how does it become a no-brainer for a normal user of Ethereum to transfer funds around and not care. I mean, ultimately, if you think about it from a usability perspective, you shouldn't care which shard you're on. It's a performance improvement thing, right? So it shouldn't matter.
Yeah.
Challenge is, how do you make it that? Like all good user experience, it takes a lot of work.
We want that simplicity, don't we?
Yeah.
Which we need.
That's where the abstraction comes. So there's complexity underneath. Once you start layering on some abstraction, then it starts getting simpler and simpler until when you're at the very top. It's very similar to like TCP/IP. TCP/IP and all of the stacks that you have for using the internet is quite deep. But as a user of the internet, you have to really pay attention to what happens at the
Cool. Yeah.
It's sort of a two-part question. So in this hybrid proof-of-work, proof-of-stake system where you've got sort of the main chain still going to be operating
Proof-of-work,
right?
yes.
And then, so in theory, once the shards are deployed, you'll have a client that's talking to these shard nodes or something like that. Is it then like sort of like how backwards compatible is it? Is there like possibility that you could still submit transactions to the main network as well as the shards? Or?
So, I guess two points of clarification. First of all, you're right, mainnet's going to continue to be proof of work because, as we talked earlier, converting mainnet to proof of stake, nigh impossible. I mean, we've talked about that whole weight of change is going to be just about, which is why this is being proposed. Beacon chain is proof of stake and the shards are proof of stake. So when we talk about FFG, we're talking about it's that overlaid on mainnet. The question is, at some point in the future, you can see mainnet as it is today not being mainnet and maybe being a shard, or maybe stuff gets pulled over onto the shards and then it goes away. That whole migration is a question that we need to answer how we put all this together, but I know in the conversations I've had, it is a question and people are asking it. So like, the classic one is, well, what happens to my ETH? And the second one was, what happens to mainnet? At what point? So right now, I genuinely have no idea, and I don't think the community has any real idea of what it's going to do. Yes?
Is there a roadmap for like deadline for decisions, like the TC 39 or whatever? They have like proposals for.
No. Look, from I started this journey only a couple of weeks ago, looking into all of this, and from what I can see, I gave you a couple of the challenges. One of mine that I didn't really dig into around the implementation challenge, which is indicated by your question, is there's no, to my view, there's not a good coordination of all of this stuff. It is still very much at that research level. There's so many things happening, which is why, that example I gave earlier, where if we were doing this ourselves, we might do all the research in here, and then we might basically go publish, that's the research, this is what it's going to be, and then, client companies, people building node clients, actually then manage it themselves, right? Or you coordinate that and then you do what they did with Byzantium. You go, hey everyone, you get your client up to date by this block, or you're not going to be able to play on mainnet anymore. There's management, right? But there's none that I can see so far. I think it's coming together, just from some of the stuff that I've seen with respect to that data of the channels. There is, I want to say there is something called the Ethereum Wizards or something I heard mentioned recently as being magicians. Thank you, that's the one. Yeah, with that view to trying to maybe bring a coordination layer in. But I don't know. And I think, to me, that is probably one of the biggest challenges, is you've got all this fantastic research. When does someone say enough? Let's just build this. And I don't know how that does. How we do that?
So we could be here like 5 years later and still talk about it.
I don't think we could, but I think we would basically not be talking about Ethereum 2.0 or anything else at that point, because you saw the block utilization, right? We need to start addressing this at some point. There are going to be problems. If we want this, if the community wants blockchain and Ethereum, for example, to be what we all hope it will be, then we don't want to be sitting here in 5 years' time thinking about this. There has to be a way to coordinate this, draw a line, and then, I hate to use it, for those who know me, I'm a Scrum Master, so we need to be agile about it. We need to get something out there and start to iterate on it, because the longer we take to get to it, we'll never pull the trigger. There'll always be a better design.
I do get a really good feel about it. So there's a lot of stuff going on under the hood in terms of there's implementation teams all over the place. Building out Pegasus is one of them. Building these beacon chain clients, and the stuff that can be built is being built now.
Okay.
So it's actually it's more the fact that there's like some gaps that need to be filled, and they're going ahead and implementing as much. It is basically an agile team in the sense that you start building what you know, get it going, and then stuff might meander a little bit near the middle of the end. But these research areas will start to drop into place as they come along. But the stuff that actually can be built is being built.
Cool. Any others?
I just want to say an example of that is like what Lumex are doing, and they've created these side chains, delegated proof-of-stake protocol, very scalable.
Massive stuff.
Yeah, and they've got JavaScript libraries to help you move ETH over to the sidechain. So despite all of this, there's still things going ahead in all directions.
Yeah. And back to what we're doing on state channels and that sort of stuff.
Excellent. Hey guys, well thank you so much. Appreciate it. Hopefully that's given you a little start. That's right. Right now,